Good evening. Bit of a dilemma. Been to Poundland, and I'm having a little bit of a conundrum. See, I bought this wonderful massage device. It's you know got a it's got a speed control. It's got well, let's take it out of its box and let's have a look. What have we got here? Very nicely packaged. Put the box over there. It's actually better packaged than some of the integrated circuits from China. Let's just slice my hands open with a scalpel. Right, so what have we got here? Put that over there as well. So we have a device that is basically a motor with an offset cam, and it says it's got a speed control, and if I put one of these Poundland batteries in it, if these are any good, these ones, it's got on and it's got off. Well, I suppose that's rudimentary speed control, isn't it? Well, that's not really sort of much good, is it? It's not much cop. I'm sure we can improve on this. I think we can definitely improve on this. This is just like a bit basic. So let's have a think. So we want to put a speed control in it. I suppose I could get a where are we? I must have one floating around here somewhere. Oh, there's one. Could I mount a pot in the back end? Drill a hole in it, mount a pot. Would that work? No, I don't think it would. Well, it would work because that's how Scalextric's cars worked. They basically had a great big wire-wound, God, I can't even say it, wire-wound rheostat. Basically one of these, but instead of having carbon tracks, it was a strip of wire, and the wiper went along it, increasing or decreasing the resistance. And in fact, it was decreasing the resistance the further along you went, so the faster the cars would go. And that sort of, all that does is limit the amount of current available to the car and changes the voltage so that your car went faster or slower. So this isn't really easy to change the voltage on. This is you've got a battery, and I suppose I could as I say, if I put that in there and then controlled the speed that way, that would, well, it would work, but it would waste a lot of the battery power in heat. So is there another way of doing it? Yes, there is actually. And I think the most efficient way of doing it is something called pulse width modulation. Let me grab a pad and see what we've got here. So, yeah, obviously used this pad before. Pulse width modulation is easiest way to describe it is as a series of pulses. So effectively, when you power the motor up, the motor starts, and as long as voltage is present, in a continuous stream, the motor will run. But what happens if you put the resistor in there? Well, for sure you will, let's draw the resistor, like so, and at the other end we'll put the motor. So if we put the two terminals and minus, and if we draw in the ground, what effectively you're doing is, well, you don't even, in fact, you don't even need to put that to ground. Let's rub that out. Horrible, yeah. Yeah, rubbers don't work very well on these pencils, do they? As long as you've got voltage, the motor will run. So if you say you had a resistor here, what would happen? Basically, you'd then lose some of your voltage in the resistor, and it would slow the motor down. Well, that's great, but all you're doing is generating heat, because you can't create or destroy energy, you can only convert the type. And the whole point of a resistor is it dissipates electricity as heat. So we need a more efficient way of controlling this motor. And rather than feed it constantly with electricity, what happens if we turned it on and off? Now I know we could, again, let's get the battery, and you get very sore hands after doing that for a while. You know, I can already feel the stress in my wrists, you know, and I haven't got carpal tunnel syndrome. Well, I would have if I kept doing that. So there's got to be an electronic way of making that happen. And there is. It's basically, why not send the electricity in a stream of pulses to the motor. Let's draw the motor in again. I'm going to put an M in the middle, M for motor, and let's put that down to ground, or the 0 volts. Okay, so this is 0, let's put that at 0, and this is plus volts. So what happens if we rapidly turn the motor on and off? So if we send lots of electricity, then no electricity, then lots of electricity, send it as a stream of pulses, we could slow the motor down, and while it's off, it's not using any electricity, is it? So that would actually make the batteries last longer. So let's work out a practical way of doing it. Now, we could do it quite easily with, I don't know, I suppose we could do it with an Arduino, but even the Arduino Nano Pro is, well, it would work, I suppose, and yeah, it could be done, but I don't think that's the best way of doing it. But let's test a principle. So if you give me a couple of minutes, I shall be back with the test equipment and the experimentation. See you shortly. Right, okay, back again, and as you see, it has been dismantled, and here is the, some would say, the most important bit, and all I've done is put the batteries outside in a little box. So at the moment nothing's changed. So as you see, it still has its zuzz, it still makes its noise, it still does its thing. I can put that back in there, I can still wedge that back in, sort of, yeah. So if I, there you go, quite noisy. And right, so what we've got to do is we've got to try and control the speed of the motor. Now, as I say, we could put a pot in there, but I was thinking rather than do that, let's try an Arduino. So let me see what we've got here. We've got an Arduino, and to save time I've already programmed it, and let's move these bits and pieces just out of the way for the moment over to this side before we make the final product. So what we have here is we have the little oscilloscope. As you see, it detects my finger plugging into the end, and here we have just a standard Arduino Uno, and we plug it in, and what's connected to it at the moment is just a potentiometer. It's being fed from my power supply and just throwing in a voltage, and I've got the output on pin 12, which is a digital output. Now, digital outputs can either be on or they can be off. So how does that help us with controlling the speed of a motor? Well, as I said before, what happens if you switch it on and off very quickly? Let's find pin 12, which is there. And I hope you can see the oscilloscope. If not, I shall turn the lighting down and just bring that over a little bit. And as you can see, the high is on and the low is off. And you can see the little LED there showing that the trigger level, and using the pot you can turn it right down until you get just very small amounts of on and lots more off. Or you could go right the other way if I keep the voltage going correctly, and you could get it so that it's far more on than off, and that will give us our voltage control. So unfortunately we can't drive the motor directly from the Uno, so we're going to need a transistor of some description just to carry the load, and here's one that'll do. Let's put this in line with our massager. So if I get the massager, it's probably easier if I clamp it to the bench, or just clamp it in the vise, and that way it will. There you go. And we need to control one side of it, so let's cut the negative wire. Right, okay, let's move some of the stuff that doesn't need to be in shot out of shot, and let's move it all to a place where you can see what's going on. Now, see, the Arduino's in. We're getting a signal from the Arduino, and that's still variable even though the motor's not running. As you see, we've got down to very little, or up to there. So if we go about halfway, let's switch the batteries on, and you can hear that the motor's running. And also see on the screen of the oscilloscope that we are still getting the signal, and it has actually put a little bit of noise on. That's because we're not using any sort of buffering or and as we turn the pot down, the motor stops, but you're getting that whine. Now that's typical of pulse width modulation, but hopefully you won't be able to hear that while you're using the massager anyway. So we can turn it up and down, and we have a perfectly working pulse width modulation controlled variable speed massager now. But this is a bit ungainly, isn't it? In the immortal words of Frankie Goes to Hollywood, there's got to be a better way. And yes, I think there is. Now, we've proved that we can do it with the Arduino. That's now. I suppose if you really wanted to get flash, you could program the Arduino to just change the speed at random intervals by itself without resorting to using a pot. That could be quite easily done. As you see, it's still shaking away. I haven't actually secured the rest of it together yet, but we'll go for that with the final. But yeah, generally speaking, that's a bit ungainly. Even if you did use a nano, you've still got a, as I say, that transistor's probably overkill, but you'd be looking at something around sort of that sort of size. So what else can we do? Well, you can get motor control kits from China, from eBay, from lots of other places, and they work in exactly the same way. So let's have a look at one of them. Let's move that over there. So we've got the power supply and we've got the massager. We've still got the scope there. So we need a cheap Chinese pulse width modulation controller. And here's one I prepared earlier in good old Blue Peter style. So what have we got here? Well, we've got an input and we've got a ground, so we need to connect our input and our ground on. So I could do that on the back of the board, a lot easier than doing it from the front of the board. So if I just dab a solder there, and the ground can go on, yeah, there for now. And we have two terminals here. Let's plug that into there and that into there. So, and again, we can vary the rate of the pulses. Now, what you can do to make this even better is you could put a pair of lithium cells in there at 3.2 volts each, so that'll give you 6 volts instead of 3. So what would happen if I up the power supply voltage? You still have variable control. So there we go. I think I'm going to box that up and make that work and make it look pretty, and get it ready to massage. Pulse width modulation, it's a wonderful thing. Thanks very much for watching. Speak to you all soon. Okay, so we're back again, and almost complete. As you see, I have mounted the cheap and cheerful pulse width board inside this little plastic box, and put the massager back together. And as with a lot of my projects on the fly, instead of using the AA size battery box, I decided to change it, and it's now USB powered. So here we go, USB power bank. Put it in the right way. And there we have variable from very gentle movement to, oh my god, it's shaking the table. Now, as you can hear, you just get the whine from the pulses in the coils. And you can rev it up as much as you like. So there we go. Just to prove that it's still pulse width modulation, let's put the probe in, and where's the negative supply side? There it is. There you have your pulses. Now, for some reason this board isn't as clean as, say, the Arduino output, but it does the job. It's good enough, and it works. I've also found that the motors on these are quite heavy current draw. They draw nearly half an amp, so really you do need a lot of batteries. The zinc carbons will run for round about 45 minutes to the hour. Alkalines may be slightly longer, and you can run it as long as you like, depending on the size of your power bank. If you really want to, there's nothing to stop you running it off mains by plugging it into the wall using a USB mains adapter, but that's up to you. Thanks very much for watching, and I hope this has been fun. It's just been a little exercise in silliness. If you like what I'm doing, please subscribe. If you don't, let me know, and we'll try and change things around a bit. Thanks very much for watching. Bye bye.